At this time, I'd like to introduce our presenter, Lisa Shoulders, Senior Product Manager for System Sensor. Lisa, take it away.
Thank you, David. Well, good morning or good afternoon if you are out there on the East Coast. Thank you for taking the time to sit in on this webinar. Today we are going to cover codes and standards and testing as they relate to duct smoke detection. The objective of this webinar is to cover the HVAC codes and standards for duct smoke detection. Then we will look at proper methods for testing duct smoke detectors. And then lastly, we will discuss the differences between photoelectric and ionization technologies for detecting smoke, specifically in duct applications, and what the preferred method is and why. The materials that we used in creating this presentation are the 2012 editions of the International Mechanical Code, NFPA 98, which is the standard for the installation of air conditioning and ventilating systems, and NFPA 72, which is the National Fire Alarm and Signaling Code. So in the first part of this webinar, we are going to walk through the requirements for duct smoke detection in the different codes and standards. I do want to note that what we are presenting is based off of national standards, and each municipality may be working off different versions of 98, 72, and a different version or revision of the International Mechanical Code. Your state and local jurisdiction may also have different requirements or have adopted different versions. So just be sure to check with your local AHJ to determine the exact requirements for your area. So first we want to recognize why duct smoke detectors are required for installation. The purpose of duct smoke detectors is to provide notification that smoke is present in the HVAC system and to shut down associated equipment, because the HVAC system sends conditioned air throughout the ductwork or throughout the entire system. And the code recognizes that duct systems also have the ability to transfer smoke, toxic gases, and flames created from a fire from one area of a building to another. The smoke and gases created in a fire event can pose a serious hazard to life safety unless HVAC equipment, which would include rooftop units, fans, and blowers, can be shut down and dampers closed to help decrease the spread of smoke and gases throughout a building. The first of the three codes that we will cover is the International Mechanical Code. The International Mechanical Code is arguably the most widely adopted for HVAC applications. It sets 2,000 CFM or cubic feet per minute as the minimum airspeed where duct smoke detectors will start being required on the return side of the system. An exception to this requirement is where open area smoke detectors are installed in all areas of the building served by the HVAC system and are then tied into a fire alarm system that will shut down all operational capabilities of the HVAC system. The open area detectors must comply with section 606.4, which I'll talk about in a couple of minutes on a future slide. But in simpler terms, it's in regard to when there is an installed fire alarm system and then the associated requirements for those situations. Another requirement of the International Mechanical Code calls for a duct smoke detector to be installed on the return side if multiple systems with a combined capacity of 2,000 CFM or more share either the same supply or return ducts. The exception here says that a duct smoke detector is not required for each unit as long as its capacity is not over 2,000 CFM. And the system will be shut down by one of the requirements listed here coming up on this following slide. So the first, if system shutdown is caused by the requirement in 606.2.1, which is the point that we just talked about on the previous slide where a smoke detector is installed on a return air system over 2,000 CFM, and then 606.2.3, which we'll talk about on the next slide, but is for return air systems that are larger and have a capacity of over 15,000 CFM. The second item here I interpret as saying if shutdown is caused by a duct or a pendant mount smoke detector in the return air plenum, then smoke detectors are not required in a multiple air handling system that shares common supply or return air ducts and has a capacity of over 2,000 CFM. Then the third point here references the exception in 606.2.1, and that states where all portions of a building are protected with open area detection that is tied to a fire alarm panel and will shut down the equipment. So then in all cases, the smoke detector must comply with the two sections listed in 606.4, which says an activated duct smoke detector must shut down all operational capabilities of the HVAC system, and 606.4.1 is in regard to tying the duct smoke detector directly to a fire alarm panel. This next requirement is for larger systems with a capacity of over 15,000 cubic feet per minute. Here, the International Mechanical Code requires duct smoke detectors to be installed when return air risers are serving more than 2 stories of a building. Then the detectors must be installed on each floor. Here, and I'll kind of expand on this when we get into the NFPA code, but the point to note here is the 2 stories, and this will come into play where the International Mechanical Code differs slightly from the requirements in NFPA. So this final slide is going to be the last really main point for the International Mechanical Code. If the building code requires a fire alarm system, as many buildings do, the duct smoke detectors must be monitored by that system and cause a supervisory signal if smoke is detected. Sending a signal to the panel would be considered sending a signal to a constantly attended location. In some cases, duct smoke detectors may be wired for alarm, but that is not typically the case. There are 2 exceptions to this requirement. The first one is if duct smoke detector is wired so that it activates the building notification system, it does not have to send a supervisory signal to the panel. But here it's important to keep in mind that in this scenario, you would be evacuating the building instead of just sending a supervisory signal. So at least in my experience, I haven't seen that done. Second, if there is not an installed fire alarm system, an activated duct smoke detector will have to send a signal to a remote accessory and provide both audible and visible indication in the approved area when an alarm condition is present. And then if there is a trouble condition, you then have to send either or, so either an audible or a visible signal. So both are required for alarm, one or the other is required for trouble. And it looks like this is our first poll question, David.
All right. Thank you, Lisa. Hopefully we answered the echo issue. Doesn't seem like it, so I'll go ahead and post the poll question, and we would ask people to respond to the poll question at this time. And we do recognize there's an echo issue on my speaker, so sorry about that. So if you can come in and vote. What is your biggest frustration with duct smoke detectors? Choose all that apply. And we'll give you a few more seconds to vote. We would like you to come back to your screen and take a look at this. All right, we got about 75% of you have voted, so I'm going to go ahead and close the poll and share the results with you. So Lisa, it looks like installation space constraints, 59%, and then detector maintenance at 48%, and smoke testing at 51%. Those are the 3 that stand out.
Okay, thank you.
All right, I'm going to take it down and back to you, Lisa.
Okay. So now we're going to move on to the requirements for duct smoke detection in NFPA 90A, which is the standard for the installation of air conditioning and ventilating systems. In this section, I'll do my best to point out where the differences and similarities exist between the International Mechanical Code and NFPA 90A. First, is the intent of duct smoke detectors per NFPA 98. Here it reiterates the same reasoning as the International Mechanical Code, that the main purpose for the installation of duct smoke detectors is to prevent the distribution of toxic smoke and gases from spreading throughout a building via the HVAC system. The preference here is that the smoke not only be prevented from spreading through the supply air side, but that the system also exhausts as much smoke as possible to the outside of the building. The first requirement in NFPA 98 is for testing, and it says all automatic shutdown devices, which include duct smoke detectors, should be tested annually. This is one of the main differences between the International Mechanical Code and NFPA 98 is that the specific testing requirements are called out in NFPA 98, whereas they're not quite as specific in the International Mechanical Code. Here, NFPA 98 differs slightly from the International Mechanical Code. They both require that duct smoke detectors be installed if the AC unit is over 2,000 cubic feet per minute. But the mechanical code calls for the detector to be installed on the return side, whereas NFPA requires the detector to be installed on the supply side. So if you are required to be in compliance with both NFPA 98 and the International Mechanical Code, you will have detectors then on both sides for supply and return for systems that are greater than 2,000 cubic feet per minute. I have heard that sometimes the mechanical engineer will design a system per the International Mechanical Code, and then an electrical engineer may design a system in accordance with NFPA, and then in that case it could be required to have a 2,000 CFM system with detectors on both sides. On larger systems that are over 15,000 CFM, both supply and return detectors are required if the system is serving more than one story. So as I pointed out in the International Mechanical Code, that requirement is if buildings are over 2 stories. So here NFPA 98 is a little bit more stringent than the International Mechanical Code. The first bullet here is very similar to one of the requirements in the International Mechanical Code, where if the entire space that is served by the HVAC system and is also protected by open area smoke detectors, then the return side duct smoke detectors are not required. A different requirement in NFPA 98 that is not included in the International Mechanical Code is that smoke detectors are not required for fans that are used for removing air from the inside of the building to the outside, as this would not aid in the spread of toxic smoke and gases within the building. It would actually help that situation. NFPA 98 also looks at what should happen when a duct smoke detector is actually detecting smoke. First, the duct smoke detector should automatically stop the fans that are wired to it, with the exception of when the return air fan is functioning as part of a smoke control system and a different mode is required for the situation. So in cases where the fan is part of the smoke control system, the system may be engineered in a manner such that the fan could assist in exhausting smoke out of the building instead of spreading it through the building. Here, NFPA 98 states that duct smoke detectors have to be installed, tested, and maintained per NFPA 72. We will go over the requirements in NFPA 72 as soon as we finish up with the requirements for 98. As with the International Mechanical Code, when there is an installed fire alarm system, the duct smoke detectors must be tied to it. But NFPA 98 requires that it be in accordance again with NFPA 72, and as I mentioned, I will go over in detail those requirements in the next section of the presentation. The second point on this slide lets us know that activation of a duct smoke detector is not required to activate a building, that the detectors are only used to shut down the equipment or to close the dampers. Here we will look at cases where there is not an installed fire alarm system. In this situation, the duct smoke detector must cause both a visual and an audible signal in a normally occupied area when activated during an alarm condition. If it were activating for a trouble condition, you would have to have either an audible or a visible signal. And this requirement in NFPA 98 is consistent with what is required per the International Mechanical Code. Some reasons that a detector might go into a trouble condition would include the unit having lost power, a cover tamper delay being timed out, or that there's some sort of wiring problems. The required visible and audible indications can be achieved by using a remote signaling device, and I'll also talk about those a little later as well. A duct smoke detector that is not powered by a fire alarm panel and is installed only to shut down an HVAC device is not required to have battery backup. The main point here is just to show that there are different requirements when a detector is or is not tied to a fire alarm panel. And this here finishes up the main points on NFPA 98. Now I will go through the requirements in NFPA 72, which is the National Fire Alarm and Signaling Code. So NFPA 72 calls out the testing requirements for duct smoke detectors. First, duct smoke detectors are required to be visually inspected at least twice every year, have a functional test that's completed each year, and have sensitivity testing completed every other year. Furthermore, as we discussed earlier in NFPA 98, it requires that all devices used for shutdown be tested annually. Though this is what NFPA states, with their testing requirements, but at System Sensor, we recommend that different environments may require testing to be done more frequently. So we always suggest that NFPA testing should be a minimum testing requirement and do more as needed per the environment that the detector is installed in. When there is a fire alarm system installed per NFPA 72, the duct smoke detector must initiate an alarm signal at a protected premises. So this would be where the duct smoke detector is installed, and this would be through the LEDs on the detector itself. Or a supervisory signal at the constantly attended location, so that would be at the fire alarm panel. NFPA 90A references this section of NFPA 72, so both codes have the same requirement. Most requirements for when a duct smoke detector is tied into a fire alarm system include, first, when the smoke detector is mounted on the ductwork, it must send a supervisory signal to the panel. Second, when a smoke detector is installed in the duct and the fire alarm system is not located in a constantly attended location and the system is also not supervised, the detector will initiate an alarm signal since the detector is not itself visible. Alarm signals are also acceptable just where there are other governing laws or standards that may cause that requirement. Remote test accessories are often required to be installed. Oftentimes, duct smoke detectors are installed above ceiling tiles or in rooftop units. So when the smoke detector is installed in a concealed area more than 10 feet above the floor or where the detector LED indications are not visible from the ground, a remote signaling accessory must be installed. The remote signaling accessory will display the detector status in a remote location, so that is visible to the appropriate personnel that will need to be seeing it. David, this brings us to a second poll question.
All right, Lisa, thank you. It seems like we still have the echo, so I'm going to speak as little as possible. Go ahead and read the poll question. When choosing a duct product feature, what's important to you? So please read the responses there and answer with whatever multiple or single feature is important to you. And we'll give you a few seconds to do that. And we do apologize for the echo. About 50% of you had voted. We'd love for all of you to come in and vote for one or multiple features that are important to you. Lisa, there are a couple questions posted here.
Okay.
The first one is, what are the requirements for duct CO detection?
Okay, that is a good question. We have had a lot of people asking that recently, but as of today, there is no specific product listing or installation standard for duct-mounted carbon monoxide detectors. We've heard rumors that there may be some requirements coming out, but to date, there is nothing that we have been made aware of.
Okay, very good. I will close the poll question and we'll publish those results here so folks can see. So it looks like that plug-in replaceable sensor head at 74%, followed closely by the flexible footprint at 50%, and multi-voltage applications as well. I'll take that down and back to you.
Okay, thank you very much. So moving forward, now that we've completed the overall code section of this webinar, we're now going to talk about duct smoke detector testing requirements and the different testing methods that are available. Okay, there are three types of tests that are recommended to be performed on any installed duct smoke detector. First, we suggest following NFPA and UL functional testing requirements. There are airflow verification and smoke response tests that can be completed. And finally, directly applying smoke to the sensor head in order to ensure the detector is capable of sensing smoke are the main varieties of testing. When performing the recommended testing on duct smoke detectors, there are a number of different options that you can use to meet these testing requirements. First, remote test accessories are commonly used for testing since detectors typically are installed in areas that are not easily accessible. The magnet test is another way of testing the detector. Most duct smoke detectors will have a built-in test feature with a push-button test and reset as functions. One of the best ways of testing a duct smoke detector is actually through doing the differential pressure testing, because this test actually verifies the detector will respond properly to smoke by ensuring there is proper airflow moving across the sampling tubes. So this is done through the use of using a test meter. It's called a manometer. Finally, the two last ways of testing are to apply smoke directly to the head or to do sensitivity testing to ensure that the detector is within its UL listed smoke limits. Okay, first, testing can be conducted with a remote test accessory. The versions that we are showing here in this presentation is our RTS2 and RTS2-AOS remote test station. They both have the same functionality, but one ships with the strobe pre-installed, whereas the other ships without the strobe installed, but it could be added as an option at a later point in time if it's deemed to be needed. So it would give you either an audible or an audible and a visible notification. These remote test accessories have the most functionality out of all the remote test stations that we have available through System Sensor. We also have other less sophisticated options that only perform testing using a key to activate the test, a push button, or even use of the magnet. The RTS2 remote test accessories are multifunctional in that they provide LED status indication in a remote location, so the LEDs on this device will mimic the LEDs on the duct smoke detector in the space in the ceiling. They provide remote testing that can be conducted via the test button that mimics the test button on the detector housing as well. And it has the ability to perform detector sensitivity testing from a remote location. we'll talk a little bit more about the sensitivity testing at a later point, but one unique thing about this detector is you are able to take a sensitivity reader directly to the accessory, test it for sensitivity, and get provided a sensitivity readout of your detector in the space up in the ceiling. This accessory also has the ability to support 2 separate sensors. So if you are taking advantage of the 2-sensor functionality when conducting testing, you'll first choose which sensor is to be tested, either sensor 1 or sensor 2. Then you can use the test button in the center of the device to complete the testing. As I mentioned, sensitivity testing can be completed at this device. The sensitivity reader that we sell is the Sense RDR, and we can purchase that through System Sensor. And when the reader is held up to the remote accessory slightly above and between the 2 LEDs on the detector, the reader will provide the sensitivity reading, so you can ensure the detector is in your required range per UL requirements. And finally, this remote test accessory will fulfill both your visible and your audible indication requirements. Okay, though there is a test button located on the power side of this detector, some AHJs still like to see the magnet testing completed. The magnet testing is done by holding the magnet up to the test magnet indicator on the sensor side of the housing. After holding the magnet in place for a number of seconds, the red LEDs should latch on, along with any accessories that the detector is tied to. All fans and associated equipment should also shut down, as well as a signal being sent to the fire alarm panel if the detector is tied to one. To reset the detector after doing magnet testing, you would press and release the test button on the power side of the detector. Next is the onboard test button. As I mentioned, it's on the power side of the detector. This push button works exactly the same as the one on the remote test accessory from a few slides back. The test button on the system sensor Innovair Flex Duct smoke detector meets both NFPA and UL functional testing requirements. One thing that is different about the system sensor test button is that it actually verifies that your detector is operating within its required test limits instead of just ensuring that the detector has power. So this is why our push button test is we're able to say that it meets the NFPA and UL functional test requirements. The testing is completed by a push and hold for test and then a push and release for reset. Next is the differential pressure testing, which I do hear is not often conducted, but is actually one of the better ways of testing duct smoke detectors. Differential pressure testing allows you to measure pressure across the sampling tubes to ensure there will be proper airflow across the detector head in order for it to properly detect smoke. So System Sensor recommends conducting this test as it tests the principal operation of duct smoke detectors. If there's any interest in learning more about differential pressure testing, we do offer a test guide that is available on our website. So in doing the actual performing of the differential pressure test, the steps in doing so are pretty straightforward. First, you need to ensure that both your sampling and exhaust tubes have been installed in the detector housing. Then you will want to plug the stoppers with the manometer tubes into the exhaust and the sampling tube ports. Then just run the test following the instructions that come with the device that you're using. And then once the test is complete, the manometer will provide you with a readout that should be between 0.01 and 1.1 inches of water if your detector is then operating properly. Next is smoke testing the sensor head, where canned smoke can be sprayed directly into the detector head in order to initiate an alarm. We always like to mention that it is important to keep in mind when conducting this type of test, it only verifies that the detector will respond to smoke. It does not ensure that your sampling and exhaust tubes have the proper airflow going across them and are functioning properly. So your sensor head may be functioning properly, but in the case of a fire, the detector may not respond as expected because you're not ensuring that you have that proper airflow within the duct smoke detector. So introducing smoke into the ductwork with canned smoke is an acceptable testing method and will ensure that the sensor is functioning properly and that the proper airflow is present. The next testing method that we're going to talk about is the use of a smoke bomb. Smoke bombs are used occasionally for testing, but are definitely not a recommended test method because it can leave a residue that may affect how the smoke sensor will function. Also, using a smoke bomb is not recommended because it creates chemical smoke, which may not represent actual smoke that would be created in a fire condition. The smoke that is generated by a smoke bomb does not have the same characteristics as actual smoke. The particles produced by a smoke bomb are larger than those created by an actual fire, and they are also what would be called cold smoke particles instead of warm smoke particles. And the cold smoke particles are typically not known to be as easily detected. Furthermore, when smoke bombs are, or the reasons that they're not recommended, is there is no standard set aside for producing smoke bombs, and they may not all be creating smoke in the same manner and may not allow detectors to respond properly. Also, it may be possible to pass a smoke bomb test and actually be out of the required range for sampling smoke with the detector, and this would then give you a false sense of security. So overall, we do not recommend testing with a smoke bomb. We recommend doing one of the other testing methods that we've spoke about already. We spoke about the sensitivity reader a little bit on a previous slide. This is the last type of testing that we're going to be talking about. As I mentioned, when we were talking about remote testing, the sensitivity test can be conducted at the accessory itself with the use of this device, which is the Sense RDR. The screen will provide an actual readout of the exact sensitivity by percent per foot obscuration. So this is a great way of getting your proper testing done. If you're utilizing the RTS2 accessory, you'll be able to get that exact reading from a remote location. Sensitivity testing can also be accomplished with use of a test magnet. The test reset button will also do sensitivity testing. And at the detector, the use of a number of different remote test accessories is available. So you could use the magnet test at the accessory or the key testing at the accessory as well. But the Sense RDR is the only option for actually receiving a sensitivity readout. There are some duct smoke detectors that monitor their actual sensitivity by the detector itself. With the system sensor option, when our detector has its blinking green LEDs, it indicates that the detector is in a standby condition and that it is operating within its minimum sensitivity limits. Okay, and the last portion of this webinar before we start getting to some of the questions is to look at the differences between photoelectric and ionization detector technologies and the method that is preferred for duct smoke detection and why. In this section, just to reiterate on this slide, we'll talk about which fires photoelectric and ionization are best for detecting and which is best suited for HVAC. First is photoelectric technology, which is the most popular and widely used type of smoke detection. The way photoelectric technology works is with an LED or a light-emitting diode that acts as a transmitter, and the photodiode acts as the receiver. The inside of the chamber is dark, and the photodiode does not detect the LED until smoke is present because of the partition that is located within the sensing chamber. When smoke enters the chamber, the light is scattered and picked up by the receiver. As you can see, it's kind of illustrated in the drawing on the slide. There then are electronics that we have, or that all photoelectric detectors have built into the smoke detector to determine the level of smoke that is present in the chamber. And when the detector determines the level of smoke is due to a fire, the detector will then go into alarm. The particular color of the smoke affects how reflective it is, which itself has an effect on the response time of a photoelectric detector. Called the photoelectric principle, colors tend to absorb light while lighter colors reflect more light. So photoelectric technology looks for a slower, colder type of fire which produces white or gray smoke with larger particle sizes. The type of smoke created by a fire depends on what is in the space and what will burn. Most items that would burn inside of a building would create a gray smoke, not black smoke. So for this reason, NFPA recommends photoelectric type detectors for duct applications due to the high likelihood that white or gray smoke will be present. Here is the ionization type smoke detectors. They are best at detecting small particle black smoke, which are typically caused by chemicals or hot flash fires and fires that you would find in industrial applications. The way they work is if you have a smoke-free chamber, there are positive and negative ions that create a small current as they migrate through or between the two metal plates. When smoke is present, the small size smoke particles get into the ionization chamber and bond with the radioactive material inside the detector. This causes a disruption in the current. The smoke particles bond to the ions and change the charge of that ion. The smoke detector then senses the drop in current between the two metal plates and then will send an alarm signal. So obviously ionization detectors are a little bit more complicated. Ionization detectors have been used forever. They were the industry standard for many, many years and were thought to respond quicker than photoelectric detectors and be less susceptible to nuisance. But we now know that this is actually not the case. And in 99% of fires, ionization detectors actually perform slower than photoelectric types. So overall, we recommend photoelectric detection, but NFPA also calls it out specifically for duct applications. As I mentioned, of the two different detection methods, photoelectric is preferred for HVAC applications, and NFPA, it states that photoelectric technology has benefits over ionization detector in air duct systems. This is primarily due to the smoke particle size found in duct applications, which is the larger smoke particles that are created by white and gray smoke. So as a summary, in duct applications, smoke particles are usually larger, which photoelectric technology responds better to. Also, photoelectric detectors are the only option for use in low-flow applications. Ionization detectors can typically only be used at airspeeds as low as 300 feet per minute, whereas photos can be utilized in a duct housing in a wider range of applications as they can be installed in airspeeds as low as 100 feet per minute, which meets the current code requirements. And also if they're used in a pendant mount application, most can typically be used down to 0 feet per minute. Okay, David, I think it looks like we're ready for our final poll question.
All right. Thank you, Lisa. I think the echoing continues, so please forgive me here. So the last question is really, how can we help you? So take a look at that, and we'll respond in kind. So would you like an application guide, product brochure, data sheet, or accessories? Or would you like to be contacted about something you heard today, maybe by a system sensor representative? So if you could go ahead and vote or select the options that are best for you. Lisa, we have a number of questions posted, and I believe you have those in front of you.
I sure do.
Let's go ahead and go through those questions.
Okay. Let's see. The first question I have here is the duct smoke activation, or is the duct smoke activation required to shut down the system/unit the duct smoke is installed on, or all HVAC systems in the area/building? First, that would really depend on your local jurisdiction and what their requirements are. However, global shutdown is not typically required any longer. I know it was at one point, but typically that is no longer the case. So I would say check with your local AHJ, but I would anticipate that global shutdown would not be required. The second question that I have here says, why do all of our local AHJs require the detectors on the supply side over 2,000 CFM, not the return? That is probably just based off of the standard that they are using. It's the International Mechanical Code says that for systems over 2,000 CFM, it should be on the return side, whereas the NFPA 90A says the supply side. So I would imagine your AHJ is going off of the NFPA requirements. Let's see, the third question says, does the International Mechanical Code address duct detector requirements for energy recovery units over 2,000 CFM? To my knowledge, they do not at this time. I've gone through the code many times and talked to a lot of people about it, and I have not heard of that as being a requirement today. Let's see, our number 4 question says, a frequent problem with smoke detection for air handling units is some don't actually have ductwork on the return side. How do you install a duct smoke detector housing on the return side in these situations? In these situations, we would recommend that the detector can be put on the supply side. If that is not acceptable to your AHJ, you could also use pendant mount smoke detectors that can be installed near return vents or in open area plenum return. So a pendant mount detector, it's just a standard open area detector on a base that is mounted to a junction box on a piece of conduit. We do offer a couple different varieties for pendant mounting that also allows you to do shutdown of equipment. The next question I have is, how can you exhaust as much smoke as possible if the unit is in shutdown? I know states are looking at this more closely. If the system is being used for smoke control or exhausting the area, then the unit may not have to be shut off of that air handler. So the way that I read the requirements is, if the fan is being used to help exhaust the smoke out of the building, then that particular unit would not be part of the shutdown. An additional question I have here is, I was told that the new mechanical code shows that 15,000 CFM rule has been written out of the code. Is this true? In the International Mechanical Code for 2012, the 15,000 CFM rule is definitely still in place. But that, again, that could be a consideration for the next revision. Let's see, question number 7. 606.2.2. Duct detectors are not required in individual power fan units, but is. Does that also mean that VAVs must shut down if they do not have an individual duct detector? That refers to common area returns or open air. So each individual unit in the entire area, all units shut down on detection. So 606.2.2 would be an example where there is limited global shutdown. Let's see if there are any other questions. Let's see, is the requirement for testing 10.4.4.2 only for conventional duct detectors, or is it for both conventional and addressable? The testing requirements are for both conventional and addressable duct smoke detectors, so all duct smoke detectors have the same testing requirements. Let's see. Another question is, does NFPA 72 allow to extend sensitivity testing every 5 years after the first 2 sensitivity tests have been performed and there have been no issues with the detector? That is true, yes. Actually, many of our customers' testing should be written into maintenance contracts for increased revenue. But yes, that can be done. We don't recommend it, but the more often that you're able to get out there and do testing, it's an additional revenue stream for you. So we recommend doing it more frequently, and just to ensure that your detector is functioning as intended. Let's see, who is responsible for testing? The customer or the alarm company or the AHJ contractor? Also, who requires the testing? AHJ or alarm monitoring contracts. AHJs require testing by code. The actual responsibility for testing is usually done by the mechanical contractor or the alarm company. But a lot of times we do hear the same sort of questions from our customers, wondering who the right person is that is responsible for doing that. But typically it is the mechanical guy or the alarm company. Let's see, I have just a couple more questions left. Let's see, which is more widely adopted, the International Mechanical Code or NFPA 90A? To my knowledge, there are only a couple of states that have not adopted the International Mechanical Code. I know that Colorado, Hawaii, Maine, and Vermont have not adopted one of the editions of the International Mechanical Code, so I would say the IMC is by far more widely adopted on a state-by-state basis, just since I'm aware of only 4 that have not. Okay, another question that we have here is, let's see, are duct smoke detectors permitted to be used as a substitute for required open area detection? The answer to that question is easy, it's no. There are requirements in the International Building Code and the International Fire Code that specifically state that it is not permitted for duct smoke detectors to be a substitute for open area smoke detection. And let's see, it looks like I just have one more question. The question is a coverage area or duct size in NFPA 72 that a pendant mount detector can be installed in? Okay, so that question is for pendant mount applications, is there a specific duct size that it is approved for? I have seen this question once before, and we did a bunch of research on it, and what we found was that for open area detectors, the requirement is 30 feet by 30 feet, but air duct detectors can be installed in a way to ensure that you're obtaining a representative sample of the airstream, and this installation would be permitted as long as you were mounting it properly within the duct, so it wouldn't, in a pendant mount application, so it was some sort of rigid mounting, so it would stay in place. And just ensuring that the sensing element has protruded into the duct, and that it's properly mounted, and that the installation through the duct is, right in the middle and is sensing as much smoke as possible, or as much as the air that's going through as possible. But there are not any sort of hard specific requirements for pendant mounting and the appropriate size of duct or damper that can be installed in. David, I went through all the questions that I was able to see. If there are additional questions, I will definitely answer those via email, if that's okay.
That would be fine. So on behalf of System Sensor, I want to thank you for joining us today. As a follow-up, we will send you a brief survey in about an hour and would appreciate your help in filling that out. We plan to reward one of you that completes the survey with a $50 Amazon gift card. Thank you for joining us. This does conclude our webinar. Have a nice rest of the day.